if alpha is a root of this quadratic equation, x square plus x plus 1 equals to 0, and the value of this sum, alpha raised to k plus 1 by alpha raised to k square of that, where k is from 1 to n, this is 20, then we have to find the value of n. Now, clearly you can see that if alpha is a root of this equation, we know that root of this equation is omega and omega is square. Right, if I have this quadratic equation x square plus x plus 1 equals to 0, so the root of this quadratic equation will be omega and omega square, and where omega is minus 1 plus root 3 iota by 2, and similarly omega square is minus 1 minus root 3 iota by 2. So in JMN you'll find the problems where they will give this complex cube root of unity in different ways. Sometimes they will give that alpha is this complex number minus 1 plus root 3 iota by 2. Sometimes they'll mention that alpha is a root of this quadratic equation. So you should be aware of the fact that if alpha is a root of this equation, then alpha is nothing but imaginary cube root of unity. Right? You can take any one of these two values of alpha. You can say either alpha is omega or omega is square. Any one of the two values will work. Here, let us say alpha is omega. For this problem, we are taking alpha as omega. If you want, you can take omega square also. It will have the same effect. Now, regarding omega, we know these two properties that omega cube is 1, right? We are familiar with these two results that omega cube is 1 and sum of all the cube roots of unity, that is 1 plus omega square, this is 0. We are familiar with these two results. So here, this is a problem basically on this formula 1. We have to observe that alpha is omega or omega square, and then this property. Now it is given that sum of this series, this is 20, then how many terms we need here, right? K is from 1 to n. So what is the value of n if sum is 20? Now let us try to figure out that if we take different values of k, then what are the terms we are getting here? If I take k as 1, then alpha raised to k means omega, and 1 by alpha raised to k means 1 by omega square of this one. This will become omega, and 1 by omega, that will be omega square, because omega cube is 1. Omega plus omega square will be minus 1, and minus 1 square will become plus 1. So if k is 1, the first term will be 1. Now let us take k as 2. If k is 2, the term will be, we are calculating this one, alpha raised to k plus 1 by alpha raised to k square. So if k is 2, the term will be omega square plus 1 by omega square of that one. Now again, 1 by omega square is nothing but omega, because omega cube is 1. And omega square plus omega will be minus 1. So this will become plus 1. Now remember, in this problem, the most common mistake is to think that every term is 1 and therefore we need 20 terms to make this sum 20. But remember, omega cube is 1. So if I take k as 3, then we'll get omega cube plus 1 by omega cube square of this one. Omega cube is 1, another one square. So this will become 4. So first two terms are 1, but the next term will be 4, right? Whenever k is multiple of 3, then each term will become 1 and therefore 2 square will become 4. And when k is not multiple of 3, then you will get this value 1. So here, basically, uh, if I have to find this sum, if I have to find the number of terms so that sum becomes 20, so first term is 1, second term is 1, and the third term will be 4. Now the same thing will repeat if you take k as 4, 5, and 6. At 4 you will get 1, at 5 you will get 1, and at 6 it will become again 4. Because if I take k as 6, then omega raised to 6, that will be 1, 1 by omega raised to 6, another one, 2 square will be 4. So now we have to see that how many terms are needed to get a sum of 20. So clearly you can see that if I take these three terms, sum will be 6 plus another 6, 12 plus another 6, 18, and we need two more terms, right? Then we can get a sum of 20. If I have to create a sum of 20, then we need these many terms. Now, as you can see that 3 plus another 3, 6 plus 3, 9, and then another two term will make it 20. So therefore, the value of n, this will be 9 plus 2, that is 11. And that should be the correct answer for this problem, right? So this was a problem where First we have to know that for this equation, the roots are omega and omega square, and therefore alpha has to be either omega or omega square. And we have this relation that omega cube is 1 and 1 plus omega square is 0. So when you take k as 1 or 2, the term will be 1, but if you take 3, then you will get 4. And whenever k is multiple of 3, you will get 4. Whenever it is not multiple of 3, you will get 1. So therefore, uh, total 11 terms are needed to get a sum of 20. And hence the correct answer for this problem will be 11.